In question 5, we have block of mass P on incline of 25 degrees. It's 6.3 kilograms. Q on the flat surface is 2.5. It's rough. We have the coefficient of friction mu down here, 0.2. It's a smooth fixed pulley, and it says Q is on the horizontal part and P on the incline. Coefficient of friction, block begins to move, show in separate diagrams, and part 2 is find A. So let's look at P on the incline first. Here we have P, 25 degrees. We have its weight, which is mg, which is 6.3 g. In this direction, we also have a 25-degree angle. So here we have mg adjacent cos 25. In this direction, mg sine 25. And we have the normal reaction. So we can say R is equal to mg cos 25, which is equal to 6.3 g cos 25, and we'll just say then that mu R is equal to a fifth of this, 0.2, a fifth of it, 6.3 g cos 25 over 5. So we write the equation for this first. We have your resisting, so P is going down the hill. We have tension in the string, so it's going down the hill, down in this direction. So it's 6.3 mg sine 25. I'll do all calculations at one point, minus what's going in the other direction, t, and minus mu r, which we have calculated. So 6.3 g cos 25 over 5 is equal to the forces equals mass times acceleration, so 6.3 a. So if we decimalize the left, I'm going to get 26.09 minus t minus 11.19 equals 6.3a. That's going to give 14.9 minus t equals 6.3a. So we need to get the other equation from Q. So we have Q on the horizontal. Q is moving in this direction if P is going down the hill. So we have mu r resistance force in this direction. We have its weight, mg, m being 2.5. We have a resistance force in the opposite direction. So the equation here, it's going in the direction of t, so it's going to be t minus mu r equals mg 2.5 g. We get mu r here, r is equal to mg, which is equal to 2.5 g. So mu r will be 2.5 g over 5. which is 0.5 g. So t minus 0.5 g is equal to 2.5 g. Sorry, 2.58. So minus like 2.58. So solving these two equations, we'll have half of 9.8 minus 4.9 plus t is equal to 2.58. So we'll get 10 equals 8.8a. So the acceleration will be 10 over 8.8 meters per second squared. And to 2 decimals, that's 1.14 ms to the minus 2 for the acceleration in question 5a. In part B, we have, I think, distance time graphs on you traveling from our house each morning. So we have Monday accelerates uniformly for 40 seconds to a speed of 22.5. So she accelerates uniformly to a speed of 22.5. So let's put that here. Anya then travels at this speed for 8 minutes. Well, we have it in meters per second, so why don't we change everything to seconds? 8 by 60, 480. So she travels along at a consistent speed until decelerating uniformly till she reaches work. And we're told that she does that at 8:30. 8:30. We're not given what time she leaves at. We know this time interval is 40 seconds. And we know that the middle time interval is 480. So we can work out maybe the distances traveled for this. Let's do the diagram maybe for part 2 as well, or for the second part of the question. Anya leaves her house 140 seconds later on Tuesday. So we don't know what time she leaves at. That's what we're going to look for today on Tuesday. So let's say she leaves later. She arrives at 8:30 the same time. So it's a similar type of graph, accelerating at 1.5 for 20 seconds. So what speed will she get? If she goes 1.5 for 20 seconds, increasing at 1.5 each second, she'll get to 30. So she's accelerating to 30, traveling along uniformly and decelerating to arrive at work at the same time. So she takes the same route to work. So along here, she's going to get to a speed of 30, and it's taken her 20 seconds. She then maintains a steady speed for 6 minutes. 6 by 60 is 360 seconds in this sector. And then we don't know the end point. What do we know though? Do we know? We know the time taken here is 520, 480 and 480. And we call this one t for the time taken. Let's see, can we get an expression for t over here? This is 140 seconds. This is 520 plus t. And from start to this point here is also actually 520. 140 and 360 and 20 is 520. So that means that this section has to be t. So we can get an expression for area with different sectors because the distance travelled is the same. So let's get number 1. So number 1 is half the base by the height, half the base by the height. So 22.5 is 225 by 2 is 450. These are in meters. Number 2 is just the base by the height, 480 by 22.5 is 10,800. And number 3 is half the base by the height, which is half of 22.5, 11.25 T. Number 4 is half, base was 20 seconds by the height of 30, so 1030 is 300. Number 5, 360 by 30, which is 10,800. And number 6, half the base, which is T, by the height, which is 30, to get 15T. So the distance covered are the same, so we can get an expression for T here. 10,8 and 450 is 11,250 plus 11.25T equals 310.8 is 11,100 plus 15T. So we'll get 3.75T if we bring this guy to the right. Bringing 11,100 over, difference of 150, so 150 is equal to 3.75T, and 43.75s are 150. So what does the question ask? Calculate the time she leaves her house on Tuesday morning. So it took her 20 seconds and another 360, so 380 plus 440. It took her 420 seconds to get to work, and gave it as an 830, so that's 420 over 6 is 7 minutes, so 8:23 to get to her house or to get to work on time.